Stars are like people. They're born, they live, they grow old, and when they grow old, they get bigger, redder, and start ejecting a lot more gas. So let's look into the life cycle of stars. They start their lives in stellar nebula, a huge cloud of gas drifting through space. Gravity begins pulling this material together, slowly at first and then faster, until the cloud collapses inward. The temperature and the pressure begin to skyrocket. Eventually, with a bit of help from quantum mechanics, hydrogen atoms begin fusing together and releasing a tremendous amount of energy. This is nuclear fusion. And once the outward push from nuclear fusion balances out with the inward pull of gravity, a protostar has been born. The size of the star depends on how much matter collapsed in the nebula. If it's roughly the same mass as our sun, a yellow dwarf forms. This is a stable star that burns hydrogen for about 10 billion years. Our sun is about halfway through this stage of its life, about 4.5 billion years old. But what happens next? A yellow dwarf main sequence star eventually runs low on hydrogen fuel. Fusion in the core slows down, and gravity starts to take the lead again, and the core begins to collapse under its own weight. This raises the temperature and the pressure until helium can start fusing into heavier elements like carbon. The outer layers of the star expand massively as the star becomes a red giant. How huge is a red giant? The red giant Aldebaran, found in the constellation of Taurus, is so enormous that if it replaced our sun, it could probably engulf planet Earth.
At least I don't have to go into work tomorrow.
But even red giants run out of fuel. Once the helium in the core is gone, the star can't fuse anything heavier, so fusion stops, and gravity pulls the outer layers away, and the star gently sheds them into space. This creates a beautiful glowing bubble of gas called a planetary nebula. And what's left behind is the core, now squeezed incredibly tightly into something about the size of the Earth, but with half of the sun's mass. This is a white dwarf. It doesn't fuse anymore, it just cools down over billions of years. Eventually, it will fade into a black dwarf, a cold, dark stellar corpse. But not all stars live such peaceful lives. If a star is much more massive, at least 8 times heavier than the sun, its story gets a lot more violent. Because of the gravitational pull of massive stars, they burn through their fuel really quickly, which means they burn incredibly brightly. Young massive stars are known as blue giants. The candle that burns twice as fast burns half as long. A massive star burns through its fuel incredibly fast, fusing heavier and heavier elements, hydrogen forming into helium to carbon, into neon, building up to iron. Now, iron is the party pooper of the elements, and it costs energy to fuse instead of releasing it. At this stage of the star's life, it becomes a red supergiant, and this happens within a few million years. Now, when the core of a red supergiant fills with iron, fusion stops. Gravity wins instantly. The star collapses in a fraction of a second, triggering a supernova, one of the largest explosions of the universe, rivaling the output of an entire galaxy. This explosion creates heavier elements like silver and uranium, everything that makes planets and you possible. What's left behind depends on the mass. If the core isn't too massive, protons and electrons get crushed so tightly they form a city-sized sphere of neutrons. This is like a giant atomic nucleus, and a teaspoon of a neutron star would weigh the same as a mountain. And if the star is really massive, even neutrons can't stop the collapse, and the collapse creates a singularity. A point that's infinitely dense, so gravity becomes so strong that not even light can escape it, forming a black hole, which is the most dramatic ending for the biggest of stars. They literally tear a hole in the fabric of space-time. But around these two extreme objects is left the supernova remnants, the leftovers of the dead star, and all of the heaviest elements that have been ejected into space. Stars don't just live and die, they get recycled. The atoms in your body were forged in stars that lived billions of years ago and exploded long before our solar system even existed. So next time you look up at the nighttime sky, remember the words of Carl Sagan: you're made of star stuff, and one day the elements that you're made up of can get recycled again into stars. If you enjoyed this sort of content, drop us a like and comment what topic you'd enjoy seeing animated next. And of course, don't forget to subscribe to The Wonder Collective. Thanks for watching. Bye!